Okay, next we're going to look at solver analysis. First, we need to make sure that the model is set up. After that, you go to data and solver. If you don't see solver here, that means you have to go and switch it on. Solver comes pre-installed, but by default it's usually uh, switched off. So you have to go to options, okay, add-ins, okay, Excel add-ins, and then you put a check mark here. Okay, if you put a check mark here, then you will see solver. Okay, then click solver. Okay, solver has three things that you have to set up. Okay, one is called the set objective, and that can be either max or min or a particular value. But we won't use the particular value. We'll use either max or min. Our objective is to minimize the MAD. So you have to specify the cell where MAD is. So that's that cell, and you have to change that to min. So that's the first thing. The second thing is what value you want to change in the model for the MAD to go up or down. Okay. And so then we can change that value and then see where that cell is minimum. Okay, and that is, okay, by changing cell is the value of alpha, and that's what we want to alter and then see for what alpha value MAD is the least. So changing cell is that. Okay, and then we have a constraint box. So that is there any restriction for the changing cell? Can the changing cell be anything, or it has to be something in a range? Well, we know that it has to be within 0 or 1. Now here we have a box here that says make unconstrained variables non-negative. So which unconstrained variable here refers to the changing cells. Okay, so this is going to make sure that the alpha is not less than 0. So we don't need a constraint that alpha has to be greater than or equal to 0. This is going to take care of that. So the only constraint that we need is that has to be, so okay, here there are several options. We want to leave it at less than or equal to 1. So that constraint is going to make sure that alpha is less than or equal to 1. That's going to make sure that alpha is greater than 0. And then there are some options. We don't have to worry about these options at this point. We'll talk about this later when we get to the linear programming chapters. Okay. Now, if the model has any non-linearity, then you have to use GRG nonlinear. The exponential smoothing formula is a nonlinear formula, and therefore you have to leave it like that. Okay. Otherwise, if it is a linear model, then you can use simplex LP, which is a much better, more efficient methodology. So if you could, you need to use simplex LP, but we can't use simplex LP in this case. All right, so now it's all set up. Now click solve. So it's going to tell you, if you set it up correctly, then it will tell you solver found a solution. So otherwise it will give you an error. If there is any problem, it will give you an error. So solver found a solution, and you want to keep it or you want to restore back to the original values. Well, we want to keep it. Okay, so that's the value at which MAD is least. As you can see, it's even smaller than that. So I'm going to just copy paste that alpha value here, okay, and put this back to 0.3 where we started. So now we have two ways of doing sensitivity analysis with the model. All right. So to recap, okay, so time series models. So we looked at these two, moving average and exponential smoothing. So we have some more trend and seasonality left. So here these two boxes refer to time series that have only random fluctuation. Okay, so the models moving average, weighted moving average, and exponential smoothing, they are appropriate for time series of type 1, random variations only.